So continuing with this problem, we were trying to see if our function value was ever 1, meaning that we were actually lying on this asymptote. So I need to take my formula for f and set it equal to 1. Now, I could work with the original formula, but it's going to be a lot easier to work with this version. I'm just going to have to remember that if I set x plus 2 over x minus 1 equal to 1, when I solve that, if I were to get x equals negative 1 as an answer, it's not really an answer because that's not in the domain of my function. So I will almost always work with the reduced form of the fraction and just remind myself that that formula isn't valid at that particular number. Okay, so how would I solve this? Well, I want to get the x's out of the denominator, so I'd simply multiply both sides by x minus 1. That way that's going to cancel here, so I get x plus 2 equals x minus 1. And now I'm going to have another restriction, x can't equal 1. Because if x was equal to 1, this would be undefined. Again, I've got to be in the domain of my function. If I tried to solve for x, I'd subtract the x over to the other side. We get 2 equals negative 1. And I say to myself, that's not true. I haven't done anything wrong. What I've shown is that there's no solution, which means we never touch this asymptote. That's very common that we don't, but it is possible to touch a horizontal asymptote. So do be prepared to check for that. And you do that by simply setting the formula for the function equal to the value of the asymptote. Okay, I do want to check for symmetry. That's another thing that we've talked about. Is this function potentially an even function, which would be symmetric about the y-axis, or an odd function, which would be symmetric about the origin? Now, I have an algebraic test for that. I know I can just plug in the opposite input. If I get the same output, it's even. If I get the opposite output, it's odd. Much easier at this point to take a look at it and say, nope, it has no symmetry by inspection. Once you've plotted the intercepts and the asymptotes, you can very often tell if there's no symmetry. If we were going to be symmetric about the y-axis, there would have to be a vertical asymptote over here, because there's a vertical asymptote over here. There would have to be a point over here, and there would have to be a hole over here. Okay? I can see things, points, holes, and asymptotes in this case, that don't have a mirror image. So this is not symmetric about the y-axis. It's not symmetric about the origin, because if it were, I could flip it upside down and it would look the same. Again, that would put an asymptote over here, that would put a point over here, and that would put a hole up at, let's see, it would be at 1/1/2. Okay. So I don't see those mirror images. Totally fine. If I ask you to check for symmetry and you can see by inspection that there isn't any, this is enough to show your work. But do write that if I've asked you to check for symmetry so that I know that you considered it. Okay, and at this point, we are ready to play Connect the Dots. Okay. Now, what I need to do is I can basically say here and here are the only places where this function could possibly change sign. Because if we're changing sign, we would either have to pass through the x-axis or jump over it. But this function, just like a polynomial, is going to be continuous everywhere where it's defined. It's allowed to jump at the places where it's not defined. So it's possible that on one side of this asymptote, my function is negative, and on the other side, it's positive. So I could sort of draw a number line, and if I just mark off the places where my function is 0 and the places where my function is undefined, because we've got that asymptote. Okay. My function is also undefined here, but it's clearly negative near here, because remember we said we were going to have a curve leading up to, suggesting that we would expect there to be a point there. So even though I don't have a point there, I can tell that my function is negative in that vicinity. So if I mark off these places, these are the only places where our function could change sign. So just like with a polynomial, I can create a number line and keep track of what sign my function is going to be. Now sometimes I may have to pick some test numbers to check. Sometimes I've already done that information. I know that to the left of -2 my function is positive. How do I know that? Well, I know that eventually I've got to be close to this point. But I can't go down here because then I'd have to cross the x-axis to get close to that asymptote. I have to end up positive because I have to end up close to +1. So I can say we got to be approaching -1, and we're going to stay below it because we've determined that we never actually touch that asymptote. Okay? Between -2 and 1, I know that my function is negative. I know that for two reasons. One, I've determined this point right here, and two, I've determined that even though there isn't a point here, my curve has to pass arbitrarily close to that. Okay. Now that tells me what happens with this vertical asymptote. I said earlier my function has to get really, really big. Could get really big in positive, or it could get really, really big in negative. Now I know it's got to be getting big in negative. So as I play connect the dots, I'm trying to make this a little bit smoother. I almost go through that point, except I skip over it because there's a hole there, and then we'll be going down towards -infinity. So this would be the left side of my graph. Now, to the right of 1, we're playing connect the dots and we have no dots. Well, I've got a couple of options. One, I could actually just pick a test number and plot a point to see whether we're positive or negative. But I can actually figure it out because I know I have to end up close to 1, and I know I have to start either way high up or way low down. If I started way low down, in order to end up close to 1, I'd have to cross the x-axis. But we've plotted the only x-intercept. I'm not allowed to cross the x-axis. And I'm not allowed to jump over it because I don't have another break in my domain. So I've got to start high up. And so my function's going to look something like that. All right. So that's going to be the graph of this particular function. Now, we've talked previously about using arrow notation to indicate the end behavior. So we were able to say as x goes to 1, as x goes to infinity, f of x goes to 1. And as x goes to -infinity, f of x goes to -1. I'd like to have a similar notation for the vertical asymptote. But the problem is, if I just write as x goes to 1, it's not clear whether I'm talking about getting close to 1 from the left side or from the right side. And I get very different behavior in the y values. Sometimes when you have a vertical asymptote, you go to infinity on both sides, or you go to -infinity on both sides. Here, my y values are going to +infinity as I come in from the right, but my y values are going to -infinity as I come in from the left. So it's not enough to say that x is getting close to 1. What I'm going to do is I'm going to indicate what direction we're approaching 1 from. So here, if I wanted to describe this behavior, we're coming from the left. I'm going to indicate that with a superscript of a negative sign. On the number line, negative numbers are to the left, positive numbers are to the right. Okay. So we could perhaps use an L and an R for left and right, but that's not the convention. The convention is we use a negative for the left and a positive for the right. Now obviously if I'm close to 1, I'm in the positive area, but I'm coming from the negative side of the number line. So this means we're getting close to 1 from the left. And then I can say f of x, that's my y values, is going to go to -infinity. And as x goes to 1 from the right, that's the positive side of the number line, what happens to my y values? They go off to infinity. So if I'm describing a horizontal asymptote, my x value is going to infinity or -infinity, and my y value is approaching a number. If I'm describing a vertical asymptote, my x value is going to a number and my y value is going to plus or minus infinity. And if it's going to infinity on one side and negative infinity on the other side, I need to indicate that with two separate statements using these superscripts of a negative sign to indicate that we're coming from the left or a positive sign to indicate that we're coming from the right.